Let's continue with limits. Again, let's look at these vector valued functions, the functions like f from R to R2, or f from R to R3. We can have higher dimensions too, like f from R to R4 or etc. And it's quite similar. There is not any real difference between the cases we talked about and the other higher dimensional cases. Now we want to talk about limit. So for example, f is from R to R2. Suppose f of x is equal to tangent of x times sine of 1 over x. That's the first component. And suppose the second component is x to the n sine of, well, maybe let me change it slightly. So it would be, I don't want to make it very complicated. Let's see. And yeah, let's say bracket of sine of x over x. That's the second thing. So this is the first component of the function, and this is the second component of the function. Okay, I should just probably remind you that by this bracket, I mean the integer, the whole value of the numbers. So for example, bracket of an integer like 1 is itself, bracket of 1.5 is 1, the bracket of 2.9 is 2. What is the bracket of negative 1.5? Does anyone know? Yeah, I got one answer. This is minus 2. It always goes toward the number which is less than our number. Okay, so 1 is less than 1 and 1.5, 2 is less than 2.9. Negative 2 is the number on the left side of negative 1.5. It's less than 1.5. Okay. Is everyone familiar with this notion? Or if you haven't seen this thing before, tell me so I remind you the definition. I'm assuming you have seen this thing before. If you have not, just ask. Okay, so maybe it's good for this question. If you haven't seen it, well, if you haven't seen it, let's forget about bracket in this question, and then I would define it for you. So for a second, just forget about that. It would confuse you if you haven't seen this thing before. Let's just forget about that for a second. So let's define this function f of x, which has two components. The first component is tangent of x times sine of 1 over x, and the second component is sine of x over x. And the question is, find the limit of f of x when x goes to 0 from left, which means x is less than 0. X goes to 0, it means x goes to 0 from left. And then if this is the set of real numbers, if 0 is here, it means x is approaching to 0, but from direction of negative numbers, not from the right side. And then find the limits. Okay, that's the question. Now, okay, so there are two limits we should compute, the first one and the second one. Let's do them one by one. First, we should compute the tangent of x, the first part, the tangent of x times sine of 1 over x. We should first compute limit of this function when x goes to 0 from left. Okay, does anyone know how I can compute the limit of something like this? Let's see if anyone has seen this thing before. Why is that? So that is true. This function, well, what you're saying is true. It doesn't necessarily mean it doesn't have limits. But let's study these functions. We have tangent of x. Tangent of x is sine of x cosine of x over cosine of x by definition, right? What is tangent of 0? Well, it's sine of 0 over cosine of 0. Sine of 0 is 0, cosine of 0 is 1. 0 over 1 is 0. Okay. That's tangent of 0. So when x goes to 0, this guy here, tangent, this one also goes to 0. Let's look at the second function here, sine of 1 over x. When x goes to 0, 1 over x goes to 1 over 0. But what is that? What is 1 over 0? Yeah, it goes when x goes to 0, 1 over 0 goes to infinity. What about sine of that? What is sine of that? Can we say what is sine of that thing? When this thing goes to infinity, well, yeah, the point is that it's not something specific. We don't know what is sine. It would change value. But although this thing goes to infinity, there is a fact we know about sine of anything. Sine of anything doesn't matter what is the value inside sine. Sine of anything is always between -1 and +1. Although I don't know the value when x goes to 0, 1 over x goes to infinity, I don't know what is sine of that. But there's one thing we know. Sine is always between 1 and -1. It's always in that area. That's true about both sine and cosine. Sine and cosine, they're always bounded between 1 and -1. So this thing here is bounded between -1 and 1. So we are multiplying something which is bounded between -1 and 1 by 0, because tangent is going to 0. What would be the result? Well, of course it would be 0. When you have a number between -1 and 1, if you multiply it by 0, you would get 0. So the limit would be 0. So if I go back, if I take limit, the first part would be 0. What about the second part? Sine of x over x. Yeah, it's something which you should memorize or you should know. So if you are not familiar with that, just memorize. The limit of sine of x over x when x goes to 0 is 1. That's kind of one of those facts which we should know about the limits. So the limit would be 0 and 1. Okay. Any question? Let's look at another. Let's look at another example. Okay, let me, this is interesting. Let me, oh yeah, sure. Here? Or the page before this one? This one? Okay. Okay. So let's look at another example. Suppose we have a function f of x, f from R to R2. Okay. Suppose the function f of x is defined as x squared minus third root of x over ln of 2 minus x. That's the first component of the function. And the second component of the function is x squared minus 1 over x minus 1. Now the question is to find the limit of f of x when x goes to 1. What is the limit of the function when x goes to 1? Okay, so the idea is always when we are in these situations, what we should do, we should first plug in x to be that number. We should see what would happen. So there are two functions, right? Function number 1, function number 2. Let's look at the first one first. So we have x squared minus third root of x over ln of 2 minus x. What would happen if x is 1? What would I have in numerator? I would have 1 squared minus third root of 1 over ln of 2 minus 1. Okay. It would be 1 minus 1, which is 0. ln of 2 minus 1 is 1. ln of 1, log of 1 is always 0. So it would be 0 over 0. Doesn't make sense. So we can't plug in just x. We can't substitute by x equal to 1. This is not possible. However, this function might have a limit at that point. Okay, so how can I find the limit? Although I can't plug in x by 1, but it might have a limit. How can I find the limit? Yes, exactly, the L'Hopital rule. Which I still don't know if it has S or not. Someone said it's both correct with S or without S. So when we have 0 over 0, when we plug in x by 1 and we get 0 over 0, L'Hopital rule says the limit of the function is equal to limit of derivative of these numerator and denominator. So I should take derivative of what I have in numerator, and I should take derivative of what I have in denominator. Okay, here I have x squared minus x to the power 1 over 3. I should take derivative of this one. Derivative of x squared is 2x. Derivative of x to the power 1 over 3 would be 1 over 3 to the power x to the power 1 over 3 minus 1, which is 2x minus 1 over 3, x to the minus 2 over 3. That would be numerator. What is derivative of ln of 2 minus x? What is the property I should use to compute the derivative here? Does anyone the derivative of ln of 2 minus x? Yeah, this is chain rule actually. So we should first take the derivative of inside when we are taking derivative. When we are taking derivative of ln of something, we should first take the derivative of inside. What is the derivative of inside? It's just -1. And then we should take derivative of ln, which is 1 over whatever we have inside. Here we have 2 minus x. Therefore, it is -1 over 2 minus x, which is the same as 1 over x minus 2. Now, we can use the L'Hopital rule here. So maybe I should erase what I have here. Okay, so this says it's equal to limit x goes to 1 of these things we computed now, 2x minus 1 over 3, x to the power minus 2 over 3 over 1 over x minus 2. Okay, now I can plug in 1 to see what would happen. Okay, in numerator, I would have 2 times 1 minus 1 over 3 times 1 to the power minus 2 over 3. In denominator, I would have 1 over 1 minus 2. It's not 0 anymore. I can just compute this thing. Actually, in numerator, I would have 2 minus 1 over 3. In denominator, I would have minus 1, and it's minus 5 over 3. So that would be the limit of the first part. That would be the limit of function number 1. Is there any question here? So there are many things here. So if you don't remember Calc 1, there are many things here which you should review. So I would just write down the things we used here. First of all, we used the concept of limits, which you should review. Then we used derivative. We took derivative here. How? We use the L'Hopital rule. Then you should remember derivative of ln or log. Then we use the chain rule. And then all of these things together gave us the answer for the limit of the first part. Okay, what is the limit of second function? X squared minus 1 times x over x minus 1. So the second function is x squared minus 1 over x minus 1. I want to know what is the limit when x goes to 1. Okay, first I would just plug in x by 1. What I would get is 1 squared minus 1 over 1 minus 1. It would be 0 over 0. Doesn't make sense. Doesn't make sense. So we can't do that. But there is something else we can do. Yes, that is correct. So x squared minus 1 is actually equal to x minus 1 times x plus 1. Okay. Therefore, x squared minus 1 over x minus 1 is x minus 1 times x plus 1 over x minus 1. And I can cancel x minus 1 here with x minus 1 here. I would end up with x plus 1. Now I should plug in x by 1. I would get 1 plus 1 would be 2. So the limit of the second function is equal to 2. So what is the final answer? The final answer is minus 5 over 3 for the first one.
Can you go back to the other page? Sorry.
Here?
Yes, thank you.
Oh, it seems I'm talking a little fast. I'm sorry. I would write a little slower. So does this thing make sense to everyone? We have 0 over 0. 0 over 0 is not defined. So what we should do is we should say x squared minus 1. We can write it as x minus 1 times x plus 1. If we do that, we can cancel x minus 1 with x minus 1 in numerator and denominator. And we end up with just this x plus 1. And then we can let x to be 1. And we would get 1 plus 1, which is 2. So the limit of the first one is minus 5 over 3. The limit of the second one is 2. So the whole limit is minus 5 over 3 and 2. That would be the result. Any question here? If you see things which you have forgotten, just write down the things which you don't remember or you don't know, okay? And then either after the class or on Mondays, we can spend time to explain these things more. Because, well, this course has, in some sense, a lot of prerequisites. So if you don't remember, the result is minus 5 over 3 and 2. Yeah. So if you don't remember some of these things, maybe on Mondays we can talk about the background. So write down the things which are confusing to you, and maybe I can explain them more on Monday. Okay. Yes, the result of this limit would be always a vector. It's always a vector form. Yes. Because the function was from R to R2, the result would be also a vector in R2. That is correct. Okay. So let's look at another function. Let's say, suppose we have f, a function from, again, R to R2. Let's say f of x is equal to x to the 4 minus 2x cubed plus 3x squared minus 4x plus 2 over x cubed minus 3x plus 2, let's say. Let's say this is the first component. And for the second component of the function, let's say we have, well, something not as complicated, something easier to handle. Okay, let's say 1 over x minus 1 minus okay, it's a little challenging to come up with the correct function now. Let's say okay, yeah, I got it. 1 over x minus 1 minus cotangent of x minus 1. Find the limit of f when x goes to 1. Okay, think about that for a few minutes. Think about it. Think about the first one first. Think about it for 2 minutes, and then I would solve that. Okay, we have one answer. Does anyone else have an answer? Okay, first, whenever we have a problem like this, yeah, we should first just plug in the number there. So if I plug in 1, what would I get? I would get 1 minus 2 plus 3 minus 4 plus 2 over 1 minus 3 plus 2. Well, 1 minus 2 is minus 1, plus 3 is 2, 2 minus 4 is minus 2, 2 plus 2 is 0. Here, 1 minus 3 plus 2 is 0. So we get 0 over 0. That's not correct. So what should I do? Well, I can use L'Hopital rule. I should take derivative of numerator and denominator. The derivative of x to the 4 is 4x cubed. The derivative of minus 2x cubed is minus 6x squared. Derivative of 3x squared is 6x. Derivative of minus 4x is minus 4. And derivative of 2 is 0. Derivative of x cubed is 3x squared. Derivative of minus 3x is minus 3. Derivative of 2 is, well, it's just 0. So we have it. We've taken derivative of both of them. Now we should plug in x equals to 1 again. So again, let's x to be equal to 1. Let's see what we are going to get. We get 4 minus 6 plus 6 minus 4 over 3 minus 3. Okay, this is again 0 over 0. We don't want that. That's what we're trying to run away from. We got that thing again. That's not good. So what can we do? What's the problem? Well, the problem is that we can use L'Hopital rule more than once. And indeed here we should do it again. So we should continue to use L'Hopital rule one more time. Okay, so here we had 4x cubed minus 6x squared plus 6x minus 4 over 3x squared minus 3. We got 0 over 0. We should use L'Hopital rule again. We would get 12x squared minus 12x plus 6 over 6x. Okay, let's plug in x equal by 1. We get 12 minus 12 plus 6 over 6, which is 6 over 6, which is 1. And that's the answer. That's the answer of the first part. So if we go back to our original function, the limit would be, what is the limit? We want to find the limit. The limit at 1, when x goes to 1, the first one would be 1. Okay, what about the second one? Now we should compute the limit of the second function. So think about the limit of the second function for a few minutes. 1 over x minus 1 minus cotangent of x minus 1. Cotangent of x is cosine of x over sine of x. That's one thing you need to know. There are other things you need to know about derivatives. The derivative of sine of x is cosine of x. And derivative of cosine of x is minus sine of x. Okay, these are two rules about derivative we need to know. Okay, how am I supposed to solve this one? I have two very different functions, right? I have 1 over x minus 1, and then I have cotangent of x minus 1. Well, cotangent of x minus 1 is, by definition, cosine of x minus 1 over sine of x minus 1. Okay? I can find the common denominator. It's just x minus 1 times sine of x minus 1. I want to subtract these two fractions. I would have sine of x minus 1 minus x minus 1 cosine of x minus 1. Now, if I let x to be 1, what would happen? if I let x to be 1, I would get sine of 1 minus 1, which is 0, minus 1 minus 1, which is 0, times cosine of 0, over 1 minus 1, which is 0, times sine of 0. Okay, this is 0, this is 0, the whole thing here would be 0. 0 times 0 here would be 0. So we get 0 over 0, and this does not make sense. So we can use, whenever we get to this 0 over 0, we can use the L'Hopital rule. L'Hopital rule tells us we can take derivative of these things. So we can take derivative of sine of x minus 1, which is cosine of x minus 1, minus. We can take derivative of x minus 1 times cosine of x minus 1. Okay, here, remember here we should use the product rule. If we have two different things like a and b, if you want to take derivative of these things, it would be derivative of first one times second one, plus first one times derivative of second one. That's the rule we should use here. So derivative of x minus 1 is 1 times second one, which is cosine of x minus 1, plus first one, which is x minus 1, derivative of second one. Derivative of cosine is minus sine. Over derivative of what we have in denominator, again, we have multiplication of two functions, x minus 1 and sine of x minus 1. We should use product rule. It would be derivative of the first one, which is 1, times sine of x minus 1, plus first one, which is x minus 1, times derivative of second one, which is cosine of x minus 1. Okay. Let's see what we have here. Here we have cosine of x minus 1 minus cosine of x minus 1. Minus, there are two negatives, they cancel each other, plus x minus 1 sine of x minus 1 over sine of x minus 1 plus x minus 1 cosine of x minus 1. Okay, here cosine of x minus 1 and cosine of x minus 1, they cancel each other. So we would get x minus 1 sine of x minus 1 over sine of x minus 1 plus x minus 1 cosine of x minus 1. What would happen if I just plug in 1 here? I would get 0 here, I would get 0 here, I would get 0 here. It would be 0 over 0. What should I do when I get 0 over 0? I should do L'Hopital rule one more time. So again, I want you to do it. I want you to apply the L'Hopital rule here one more time to see what we are going to get. Okay, I would give you some time to do that. Okay, so we should do this thing one more time. So let's continue with that. So we have x minus 1 sine of x minus 1 in numerator, and we have sine of x minus 1 plus x minus 1 cosine of x minus 1 in denominator. We should do L'Hopital rule. Here we have product rule. Yeah, good. So it would be derivative of x minus 1, which is 1 times sine of x minus 1, plus x minus 1 times derivative of sine, which is cosine of x minus 1. Then we should take derivative of denominator. Derivative of sine of x minus 1 is cosine of x minus 1 plus derivative of x minus 1 times cosine of x minus 1. Again, we should use product rule. First, we should take derivative of x minus 1, which is 1 times cosine of x minus 1, plus first thing times derivative of cosine, which is sine of x minus 1. Okay, now we should plug in x by 1. Sine of 1 minus 1 would be sine of 0, which is 0, plus 1 minus 1 would be 0. 0 times cosine would be 0. Cosine of 0 minus 1. Well, 1 minus 1. It would be 0. Cosine of 0 is 1. That's the important thing. Cosine of 0 is 1. Plus. Here we would have, again, 1 minus 1, which is 0. Cosine of 0, again, is 1. Plus, well, x minus 1 is 0. 0 times anything is 0. So we get 0 over 2, which is 0. We didn't get 0 over 0 anymore. We got 0 over 2, which is 0. So if we go back to our problem, the second part goes to 0. So the limit of the whole function is another vector, which is 1 and 0. That would be the limit of this vector valued function. So as you can see, it's kind of similar to what we had in Calc 1, but or Calc 2, but we just end up with vectors rather than numbers. The limit of our functions now, they are vectors. Okay. Is there any question here on how we did L'Hopital rule here? So make sure this thing makes sense. Well, sometimes you might need to. I mean, it depends on the question. Sometimes the L'Hopital rule might not work. Sometimes you might do it one after another, and you wouldn't get out of it. You would end up with 0 over 0. But in the questions that you would see, probably this thing wouldn't happen. Okay. Now there is another kind of limit which we need to. Oh yeah, 0 over 2 is 0. Yeah, we don't need to continue here. Here we are done. Okay, there is another example of the limit. Suppose we have a function from R to R2. Say f of x is, say the first component is ln of 1 plus e to the x. No, not exactly. Say it's ln of 1 plus e to the x over x. Say that's the first component. Say the second component is sine of 2x plus 2x plus 2 over e to the sine of 2x times 2x plus sine of 2x. Now the question is that what is the limit of f? Well, the other case which we didn't review yet is when x goes to infinity. Here, say plus infinity. What is the limit? Okay, we have two functions, 1 and 2. Let's think about 1 first. Let's see what is the limit of ln of 1 plus e to the x over x when x goes to infinity. Well, if you just simply plug in x by infinity, you would get ln of 1 plus e to infinity over infinity. It's just a formal computation. It really doesn't have a rigorous mathematical meaning. But anyway, if I just let x to be infinity, this is what I'm going to get, right? What is e to the infinity? What does it mean to raise a number by infinity? What should it be? What would be the value of e to infinity? Can anyone guess? Yes, infinity. So this thing here would be infinity. And then we have infinity plus 1, which again is infinity. If you add 1 to infinity, you wouldn't change it. And then you should take ln of infinity, which is still infinity. You still would end up with a bigger another infinity. So that would be infinity over infinity. And infinity over infinity does not make sense. So we can't just guess the answer simply by kind of letting x to be infinity. We should find another way to solve this one. What other way do you think might work? How can I compute this? Yeah, L'Hopital rule might work. That's not a bad idea. We can see. maybe we can simplifying with what? What with what? What should I simplify? Well, say L'Hopital rule is one suggestion, but I don't see anything to simplify actually with something else. Yeah, that would be a more complicated argument. Let's see if we can use L'Hopital rule. If it doesn't work, we would go towards the more advanced techniques. But let's see if we can use L'Hopital rule. Try L'Hopital rule, see if it works. I will give you 2 minutes. Try to use L'Hopital rule here. Okay, yeah. So let's use L'Hopital rule to see what is the limit. We have ln of 1 plus e to the x over x. And they both go to infinity. So it's kind of is an example of infinity over infinity. Now, L'Hopital rule tells us we can take derivative of numerator and derivative of denominator. Derivative of denominator is 1. It's simple. What about numerator? When we have ln of something else, we should first take derivative of what is inside. Derivative of 1 is 0. Derivative of e to the x is itself, is e to the x. Derivative of ln is 1 over whatever is inside ln, which is 1 plus e to the x. Okay, if we do the multiplication, we would have e to the x over 1 plus e to the x in numerator over 1 in denominator. Okay, x is going to infinity. If we plug in x by infinity, we get e to the infinity in numerator, which is infinity. 1 plus e to the infinity in denominator, which is infinity. It would be infinity over 1 plus infinity. That's again infinity. That doesn't work. It's not what we're looking for. So we still didn't get to the answer. What should we do? The idea is that we should use L'Hopital rule one more time. I should take derivative of numerator and derivative of denominator. Derivative of numerator would be e to the x. Denominator, derivative of 1 is 0. Derivative of e to the x is e to the x. So it's just e to the x over itself, and that's 1. Anything over itself is 1. So the limit of this function is just 1. Okay. Is there any question here? So we did the L'Hopital rule twice. Okay, so the function converges to 1 in this case. The limit would be 1. So the final result would be 1 for the first one. What is the limit of the second one. I think that's enough of limit for today. Maybe you can think about that later, okay? So you can write down the second one and think about it for yourself. I think we did enough of these limits. Okay, is there any question about this section about limits? So we covered the domain and the limit. These are two parts we covered. Is there any question from these two subjects? No, well, the question someone asked, we are not solving the second part? No, I think I can, but I think it's enough. We did enough practice on limits. That's a good thing for you to think about, the second part. Okay. Okay, so I think for the second, actually the second part doesn't, okay, let's solve the second part too. If you think, if you want to know the answer, we can do that, why not? Let's do the second part too. Sine of 2x plus 2x plus 2 over e to the sine of 2x times 2x plus sine of 2x. Yes, the format of the midterm is similar to the practice exam. If it wasn't similar, what would have been the point of the practice exam, right? The practice exam is supposed to be something which introduce the format of the exam to you. Okay, so here x is going to infinity, and the question is, what is the limit of this function? What is the limit when x goes to infinity? But, well, if I just plug in infinity, it would be sine of infinity plus infinity plus 2. Well, infinity plus other things would be infinity. And then in denominator, we have e to the sine of infinity. Sine of infinity is something between 1 and minus 1. Sine of anything is between 1 and minus 1. So it would be e to some power there, times infinity plus infinity. Well, it seems we have another infinity over infinity. So it doesn't work like that. We should do something about this infinity over infinity. Think about it for 2 minutes. Let's see what we can do with this function. Okay, let's see. So here again, we are going to use the L'Hopital rule. We have 2, 0, 0 does not exist. Okay, let's see. If I use the L'Hopital rule, this limit should be equal to derivative of what I have in numerator over derivative of denominator. Okay, let's start with sine of 2x. What is the derivative of sine of 2x? Well, we should first take derivative of what we have inside of sine. Derivative of 2x is 2. Then we should multiply it by derivative of sine, which is cosine of 2x here. Then we should add the derivative of 2x, which is 2. And then derivative of 2, which is 0. That's the numerator. What about the denominator? In denominator, we have multiplication of two functions. So we should use the product rule. We should first compute the derivative of first part, e to the sine of 2x. What is derivative of e to the sine of 2x? Again, I should first compute what I have here inside. I should compute the derivative of e to the sine of 2x. First, I should compute the derivative of the power, sine of 2x. What is derivative of sine of 2x itself? I should look at what I have inside, which is 2x. Its derivative is 2. I should multiply it with derivative of sine, which is cosine of 2x, and then derivative of e. But derivative of e is just e, so it would be e to the sine of 2x. Am I right? I'm not 100% sure if I'm computing the derivative correctly. Let me tell you about, well, I'm not 100% sure. It might be a trap. So let me think. Yeah, I'm computing the derivative correctly. Let's continue. It would be derivative of first one times the second one plus first one, e to the sine of 2x, times derivative of the second one. Well, derivative of 2x is 2. Derivative of sine of 2x, we should first compute the derivative of what we have inside, which is 2, times derivative of what we have outside, which is derivative of sine, that's cosine of 2x. Okay. So x is going to infinity, right? What does it tell us? Looks very complicated. The people who computed this example, what did you do? I mean, what can I do now? Just unmute yourself and tell me what I should do at this point.
So what I did was I saw that there's only 2x left in the equation, and the 2x is the only term that goes off to infinity.
That is correct. So you didn't continue the L'Hopital rule, right?
No, I did not.
Okay. Yeah, I will thank you. You're right. That's the correct way to do it. I just want to see if anyone could use the L'Hopital rule to compute the answer. Okay, so it seems there's no one who really could use the L'Hopital rule. So let me explain what I think Adam just said now. And that would be the honest way of computing the limits. Like, if you have a little bit experience of computations, a lot of times you wouldn't go into all these computations. So let's look at the function one more time. Oh yeah, okay, thank you. I thought it was Adam. That was Christopher who gave the answer? Okay, it's good. Yeah, you're thank you, Christopher. Yeah, maybe every time that you want to give an answer, you can introduce yourself to everyone and then give the answer so we would know you. So, okay, let me tell you. So the idea was sine is always, doesn't matter what it is, it's always something between +1 and -1. Okay, here we have something between +1 and -1. Here we have 2. So I'm adding 3 things. Something which is between +1 and -1, and 2x which goes to infinity, that's infinity. When x goes to infinity, 2 times infinity would be infinity. And then I'm adding 2. Well, between these things, to be honest, infinity plus other things is still infinity. So if you add 2 to infinity, or you wouldn't, it really doesn't matter. You know, if you have infinity $billion, it really $2 really doesn't matter for you. So when you have infinity, it really doesn't matter if you add 2 to it or not. It really doesn't matter if you add something which is between +1 and -1 to infinity or not. The only thing which matters here is 2x, because 2x is the infinity. Now look at the denominator. 2x again here would be infinity. Sine of 2x would be something between -1 and +1. If I add something between +1 and -1 to infinity, it still would be infinity, and it doesn't change anything. I really don't even need to write sine, something which is around -1 and +1. the only thing which I can even erase this sign of 2x. I don't care about that those small numbers when I'm dealing with infinities. If I do that, what remains is e to the sine of 2x times 2x. And then I can cancel 2x with 2x. What remains is 1 over e to the sine of 2x. Now, when x goes to infinity, what is the value of sine of x or sine of 2x? The point is that we don't know. When x goes to infinity, sine doesn't converge to anything. This limit does not exist. The sine would oscillate. Sine is like that. It doesn't converge to anything. So it wouldn't converge to anything. Therefore, e to sine of 2x wouldn't converge to anything. And therefore, 1 over that doesn't converge to anything. Therefore, this limit does not exist. So if we go back to the original question, the first one goes to 1. The second function doesn't converge to anything, does not exist. So in total, the limit of the function doesn't exist. So the final answer would be the limit of the function does not exist. So there's a question about how I got 2x above. Let's go back. Where were we? We were here. So how did I get 2x? Is that the question? Okay. So I said sine of 2x is very, very small. It's something between +1 and -1. 2 is also very small. 2x, when x goes to infinity, is 2 times infinity. So when 2x is kind of like infinity, adding 2 to it, or adding sine of 2x, which is something between +1 and -1, they don't even matter. So I can just erase them. It's like adding 2 to infinity doesn't make any change. So it really doesn't matter if I add 2 or not. Or sine, which is something between +1 and -1, it doesn't matter if you add that to infinity or not. I can just erase that. I don't care about something so small anymore when I have something in the level of infinity. So only 2x remains.
I mean, so you leave this 2x here is for canceling with the 2x in the bottom, right?
Yes, and then, well, there is also 2x in the bottom. Then we would cancel them. That is correct.
Okay, thank you.
Yes, good. Okay, so that would be the conclusion for limits. That was the limit of vector valued functions. So let's have a break. Let's continue at 2:30 in almost 10 minutes. And we would get to the next section. Okay, so let's have 10-minute break.